Hello, good afternoon. Khushamdeed, benvenuti, benazvenit, marhaba. The aim of this presentation is to understand the data integrity, CSV principles, and IT infrastructure qualification, which is compliant with FDA, Gxp, or EU requirements, including 21 CFR 11 and INEX 11. The focus is to understand the IT infrastructure qualification strategy, that is the IT infrastructure, and what is the IT infrastructure life cycle, IT infrastructure maintenance, virtualization, and the approach for cloud computing qualification. So basically the topics for today is IT infrastructure qualification strategy. We'll define also IT infrastructure qualification life cycle, IT infrastructure maintenance, and what is virtualization, overview and compliance, and about the cloud computing and the qualification approach used for the cloud computing. So let's start with the IT infrastructure qualification strategy. In this section, we will explain what is the difference between validation and qualification and the IT infrastructure qualification strategy. So basically, what is validation and what is qualification? Validation is the term used to deal with user requirements and is about the process manually, while qualification focus on the components, system, or equipment which works properly and how it is designed, and also that the application is working in a manner as it was designed. So the basic difference between the validation and qualification is validation focuses on the requirement of the user or on a process, while qualification demonstrates that a component or equipment work on that application functions as it was designed, and that the infrastructure functions as is designed in terms of hardware, data transmission capabilities, and bandwidth. To qualify a platform, at first we have to consider if it is Gxp relevant or not. If the system or applications are Gxp relevant, then it must be qualified, and everything should be documented. As if it is not documented, if is not documented, then it do not exist. So what IT infrastructure, why and what IT infrastructure need a qualification? When we speak about IT infrastructure qualification, we need to qualify the clients, we need to qualify the servers, networks, and network services. The server room utilities need to be qualified as well, and the IT infrastructure software should be properly qualified, while the Gxp applications need to be validated. IT infrastructure qualification we do in different phases, and there are different deliverables depending on the projects. So basically, IT infrastructure qualification is explained in this phase and the deliverable of this project, and how we maintain the qualified state of this IT infrastructure with a set of procedures. So these standard SOPs, they are a few, just like standard SOPs, IT change control, IT configuration management, backup and restore, IT security, IT incident management, and IT periodic review. So these are basically important to just keep our IT infrastructure in a qualified status. So what is basically the life cycle of the IT infrastructure? In this section, we'll detail the IT infrastructure qualification life cycle and how it should be done in compliance with the regulatory requirements. So basically, first of all, we have the qualification plan. The qualification plan where we define the scope of qualification activities, objectives of the projects, the deliverables, and the team who will be involved and responsible for this project. All this will be documented and detailed in the qualification plan. And to address the required activities, responsibilities, procedures, and timeline to assure that the qualification, which provides an overview of the Gxp relevant IT infrastructure together with the company IT qualification strategy. The qualification plan basically defines all qualification activities, key document deliverables, roles and responsibilities for reviewing and approving the documents, and the high level acceptance criteria, and it clearly defines the IT infrastructure in scope of qualification activities, which can be conveniently grouped in areas like network, server, client, server room, and IT infrastructure. So basically, when we are done with the plan, so we move to the next section, and which is very important. So we have to do a risk assessment. After the qualification plan, we have to determine the risk involved, where risk assessment is to present an overall risk-based approach for the qualification of IT infrastructure according to the applicable standard and the current interpretation of the applicable regulations. IT risk assessment specifies the guidelines for classifying and assigning the Gxp relevance to each IT components for determining the depth of qualification activities. So here we have basically the component impact assessment, non-controlled component versus components of IT infrastructure areas. Then we have Gxp Relevance Assessment. Gxp Relevance Assessment is to be performed on the components of IT infrastructure to identify the homogeneous relevance regions. The Gxp relevance should be determined as high, medium, low, and null. So for example, we have the high, where we have the high Gxp relevance. So the components constituting IT infrastructures deemed to have potential impact on integrity and or confidentiality of Gxp critical data. So for the medium relevance, the components of IT infrastructure deemed to have potential significant impact on availability of Gxp critical applications. So they are low, and also the null Gxp relevance, which we'll discuss in the upcoming slides. So Gxp relevance assessment. So basically, the qualification activities will be based on Gxp relevance of IT infrastructure components, and this will give input to the test strategy. During the Gxp relevance assessment, we identify the IT infrastructure components, and that will be later used for the testing purpose. The components with the high and medium Gxp relevance will be testing during the IQ and OQ testing phase, while the components with the low and null relevance will not be part of the qualification test activities. And now we move on to the approach for IT infrastructure software tools. IT infrastructure software tools are used to manage the operating environments, therefore they should be considered on the risk-based approach. Those tools are used to set up, protect, monitor, and manage the computing environment and network. The way they are used can change the GUMP category they belong to. If they are the only tools for the managing fundamental processes such as configuration management for regulated applications, IT infrastructure software tools come under GUMP category 1 and assessed during the risk assessment. These tools are must to be reported in the design spec document, including the version numbers, and must be tested during the IQ testing phase. And risk assessment for IT infrastructure tools are evaluated during the risk assessment and should be determined with the proper risk category as low, moderate, and high. The design, after the successfully assessing the risk, then we'll move forward to the design specification. So basically the design specification describes in detail the hardware and software structure of the infrastructure components, making reference to the specification of the software application depending on this IT infrastructure. So these are subject to qualification all of the IT components, IT infrastructure components, and they must be adequately identified and described. It can also include information related to system equipment such as manufacturer, model, serial number, and main characteristics and other related information. Moreover, the design specification lists the technical documentation regarding the hardware and software technical specification for all the IT infrastructure components in the scope. So when we have defined everything in the design spec and we described all the devices, the network topology, and all the stuff, then we just move to the test strategy. So basically in the IT infrastructure qualification, the test strategy is oriented to provide documented evidence of the IT infrastructure configuration and reliability. The testing phase is executed by the QA qualification service head with the support of the relevant head of IT platforms technical stream. The testing of IT infrastructure qualification includes the following phases: IQ, which means installation qualification testing, and OQ, which means like operational qualification testing. So when we speak about the IQ test strategy, the IQs, let's say we have the network area where we have the devices like switches, routers, firewalls, and access point. Firstly, we analyze the network topology, and by considering the device criticality, the network's area should be just identified, and then we have to identify the devices. If they are critical devices, then we have to test, and we have to do the IQ testing on these devices. And then we have the physical servers, virtual server, blade enclosures, storage, and FC switches, that all should be tested. But we can exclude the servers which are tested as a part of any previous validation process. So if some servers, they are qualified already, are validated in some other stream, so we might include that devices, that servers, to don't test again. So when we speak about the server, so basically physical servers, we have to qualify the critical ones. And when we are speaking about the virtual servers, so basically we have to choose the virtual servers also, which need to be testing during the IQ phase. As a significant sample can be chosen by analyzing the criticality of these servers. So for example, the domain controller, antivirus applications, backup, and mail servers, these servers we are critical, and we need to just test them in the IQ. Then we have the clients. So for the clients testing set strategy, we only one PC client must be tested in order to verify the consistency of the information stored in the automatic tool. This PC will be selected randomly with departmental clients, label printers, and handheld devices, and that could be out of the scope if they are already included in the validation strategy of Gxp systems. And then we speak about the server room area. So basically, when we are speaking about the server room utilities, they are important for the data integrity, confidentiality, and availability, and the physical access to the server room also is important. So that should be limited to the authorized person, and physical security if there is some badge reader or some any access, any restricted access. So we should have to qualify also these utilities need to be tested during the IQ phase. So for example, we have the UPS, we have anti-fire systems, or we have environmental control or monitoring systems that should be tested and qualified and tested in the IQ phase. So next we move to the OQ phase. So the operational qualification testing, basically we confirm the correct operation of the infrastructure components and their associated operating system software to make sure they are operating the way they are designed and supposed to operate. So the OQ testing provides the documented evidence that key functionalities of the network system and security adhere to proper design specification as described in the design specification document according to company standard and vendor specification by using transversal approach. For an example, in case of firewalls, we can test that the data is accessible only through the permitted path, and any attempted path access to the block area will not be possible. So basically we can see this network segregation and the security, firewall security rules. So we can do a OQ test to verify all the scenarios. So the following OQ tests are the standard tests which are tested during this phase, depending on the IT infrastructure of the company and also the criticality of these tests. So basically we have the first test is like general prerequisite. So if there are some prerequisite for the OQ test, so basically we verify these. Then we have the SOPs verification. So basically we spoke about the standard operating procedures for IT maintenance, security, and configuration management. So basically we have to verify all the standard operating procedures which are already in place, approved, and we should just verify in a test. Then there we have the network mapping connectivity. Basically in the network mapping, just we confirm the connectivity of the network, and then in the next test we just test the network traffic. Then we have the security testing where we are testing the management console verification. Then we have VLAN accessibility or segregation. So basically with the virtual LANs, if we can access or if there is some restrictions, so depending on the company policies. Then we have in the security testing we test also the network access. Then we have the port scan test. Then we have the backbone redundancy, and there is some set of the OQ tests which we do to qualify the IT infrastructure. So once we are done with the IQ and OQ, then the final stage is the process of qualifying IT infrastructure is to issue a final report that summarizes the result of the planned qualification activities and formally close the qualification process. In the reporting phase, we describe the performed activities and list the issues deliverables in order to demonstrate proper and complete execution of the qualification process, including any non-conformity or follow-up. After the conclusion of the testing, the functions involved in the qualification activities verifies that all actions defined in the qualification plan have been adequately completed. A summary report must include details of the operational environment, procedure, and control that will govern the use of management of the infrastructure after its release. Any pending action addressed in the qualification report will need to be followed up in order to monitor the relevant completion of this project. So there are basically some standard procedures. So we spoke also before that to maintain the IT infrastructure in a qualified state, we need to have a set of SOPs in place. So to maintain and manage the Gxp shared domains in a control status, there should be some standard operating procedures in place, which includes, but they are not limited to, IT change control and configuration management. The change control is the mechanism which basically enable to manage in a controlled manner the implementation of those changes which are evaluated as impacting IT infrastructure components and determined as Gxp and therefore affecting the qualification status of a system. For Gxp IT domain, the change control process is established as from the initiative of the qualification testing phase to ensure that any changes is tested before the implementation in the effective environment. The change control process shall be based upon the list of IT infrastructure components determined as Gxp critical and identified in the configuration management database, which is implemented according to the relevant standard. So the change control procedure should be in place, first of all, to properly manage the changes and to document all the changes. So that procedure should be in place. Then we need to have a backup and restore procedure. So basically the backup procedure are necessary to assure the safeguard of the software and data managed by the computerized system. These procedures have the objective of assuring that in case of failure, fire or other negative situations, one copy of all the fields and program is available. The control measures implemented by the company must ensure that data of each computerized system shall be copied at regular intervals according to a formalized backup procedure for the system protection against possible crashes. Backup media are stored in secure location and prior to release of the Gxp computerized system running on the IT infrastructure, the scheduling of the backup activity shall be defined and operational. And the most important thing is the procedure of backup and recovery required to be tested formally before the final implementation to ensure their correct functionality. So they should be functioning. Then we move to the IT security. The current security of IT procedure must assure the control access to the area where the IT infrastructure are in control, both from a physical and logical perspective, to ensure the protection of data integrity. All the operations shall be identified through the user accounts which shall be determined and maintained. Then we have IT incident management. For every measure used to record and analyze all reported incidents and underlying problems has to be enabled corrective actions which are defined in a logical model. So then we move forward to the security management. So the security management basically is describe the physical and logical access must be in place to ensure that IT infrastructure system fulfill current security requirements. And the last but not least, we need to have a disaster recovery plan. So that should be in place in case of any major outage, if there is some earthquake, some flood, some natural disaster. So we should be able to have a disaster recovery plan to just for the business continuity. So here we spoke about the IT infrastructure qualification life cycle, and now we move to the virtualization overview and compliance. So basically we'll discuss here what virtualization is and how to qualify the virtualization platform. So virtualization is the processing of running a virtual instance of a computer system in a layer abstracted from the actual hardware. Most commonly, it refers to running multiple operating systems on a computer system simultaneously. Virtually can be considered as a So virtualization pros and cons. Virtualization enables multiple operating systems to run on the same physical platform. The pros and cons for the virtualization platform are here. Provisioning time of server clients, high efficiency, energy space, disk space, centralized management of resources, networks, and standardization of service architecture, lower impact on validation, hardware, software, independent, thin client, tablet, maintenance, obsolescence, standard spares, high availability, centralized backup and disaster recovery. And cons: higher initial investment cost, higher skills required for system management, risk of hardware failures. So basically qualifying the virtual infrastructure is very similar to the traditional IT infrastructure qualification. Here we qualify virtual infrastructure as a platform. We mostly look into verifying hardware, layer software, configurations, backup and recovery. We qualify the virtual templates and virtualization management softwares, for example VMware, vCenter, and all these efforts are based on the risk assessment. So virtualization management software hypervisor used for virtual machines monitoring are classified as category 1 in GAMP 5. It provides a single point for managing virtual hosts and provide essential services such as access control, performance monitoring, and configuration of the virtual machines. So in today's scenario, to cope with the current market situation, the business require more and more fast solution and must change to succeed in the information age. Today, cyberspace and industry are no longer separate entities, and that's why business requires more and more fast solutions. So, the most important topic, the interesting topic of today is that cloud computing. We hear a lot about cloud computing, and in these slides, we'll discuss what the cloud computing means actually. So while we are using the cloud computing, so basically cloud computing is the use of hardware and software to deliver a service over a network, typically the internet. An example of a cloud computing provider is Google's Gmail, Skype, YouTube. Gmail user can access files and applications hosted by Google via the internet from any device. In fact, we are using the cloud computing from a long time. So basically, what is the cloud computing? The definition of cloud computing according to the National Institute of Standards and Technology is model for enabling convenient on-demand network access to a shared pool of configurable computing resources. For example, networks, servers, storage, application, and services that can be rapidly developed and implemented with minimal efforts. So this is basically the cloud computing. Then we go further and we see there are some models in the cloud computing. So cloud computing can be broken up into three main services: software as a service, SaaS, infrastructure as a service, IaaS, and platform as a service PaaS. These three services make up what is called the cloud computing stack, with SaaS on top, PaaS in the middle, and the SaaS on the bottom. So basically how this model work. The first cloud computing type is infrastructure as a service, which is used for internet-based access to storage and computing power. The most basic category of cloud computing types. Infrastructure as a service lets you rent IT infrastructure, server and virtual machines, storage, networks, and operating system for a cloud provider on a pay-as-you-go basis. The second cloud computing type is platform as a service that gives developers the tools to build and host web applications. PaaS is designed to give users access to components that requires to quickly develop and operate web or mobile applications over the internet without worrying about setting up or managing the underlying infrastructure of servers, storage, network, and database. The third cloud computing type is software as a service, which is used for web-based application. SaaS is a method for delivering software applications over the internet, where cloud providers host and manage the software applications, making it easier to have the same application on all of your devices at once by accessing it in the cloud. So the type of the clouds. So the cloud can be divided in public, private, and hybrid. So for example, Gmail, iBox, CloseBank, and the medical records of some hospitals are all cloud-based services. Yet they are very different. There are three main categories of cloud hosting, which is public, private, and hybrid. Public cloud solutions are readily available from Google, Amazon, Microsoft, and others. Private cloud services are provided to the internal user from a business data center, while hybrid is a combination of public cloud services and on-premises private cloud. So basically it's the mix-up of public and private, so that is called hybrid. So the interesting question is what approach we use for the validation of these services. So the risk-based scenario for the different services model are here. So for the SaaS, if that is in the house, so we validate the system, and if it's public, then we focus additionally on supplier testing and qualification, and if it's hybrid, then is a combination of risk scenarios. So same is for the PaaS and IaaS. So basically they required the qualification, but we use different strategies to qualify this. So what are basically the compliance issue? For data access and data availability purpose, data might not be stored in one place and may not be easily retrievable. The risks are when using the cloud services, there is no guarantee that an enterprise can get its information when it needs the information. So make sure in case data is requested, if data is requested by regulatory authorities during the inspection, it can be provided without compromising other information, and it should be available. The cloud provider must be able to demonstrate the reliability of the services and the recovery of the data in case of disaster, as data on the cloud is mostly encrypted to ensure the security of the data. But if corrupted, the encrypted data is most harder to recover than the unencrypted data. So for the cloud computing, the general approach is we do a vendor assessment, risk assessment, where we ask for a disaster recovery plan. Most importantly, change control and configuration management needs to be defined as well. And apart from this, continuous monitoring is also required as a part of validation maintenance process. So these are basically the important factors for the cloud computing. So here we conclude we learn in this presentation basically. So the why we do qualify the IT infrastructure and what is the life cycle of the IT infrastructure. Then we speak about the cloud computing and the virtualization platforms. So how do we qualify the virtualization platform, virtual platforms, and the cloud computing. So basically using this approach we do qualify the IT infrastructure. So thank you very much for your time and patience. See you again. Cheers and bye bye.